ya. I caught you. You're coming here to cheat. No, you're not. You're coming here to learn. You're going to learn some good math. Listen, if you haven't tried these problems yet, try them on your own. This is going to be the Algebra 2, August 2018. My name is Mr. Key. No, my name is Mr. Krause. You can call me Mr. Key. By the way, this is going to be parts 2 through 4. My handwriting gets slightly better. Only slightly better. Yes, of course I have some coffee. It's Dunkin' Donuts, trust me. Trust me. It's freshly made downstairs, though. All right, let's go. Okay, so you're on your own. No more calculator cheats. You have to now work. But I do have some ways to check your answers, and I cannot stress it enough. Don't make silly mistakes and not check your answers. That's just cray-cray. That's how the cool people talk, by the way. I don't know if you know that. That's what cool people talk like. Yeah. All right, we got to factor this thing. And I'm going to show you the way to check this, sort of. So what we're going to do is toss this into 2 sets of parentheses. Now, we got a whole bunch of people get freaked out by the fact that that's x to the 4th. But isn't x to the 4th really just x squared times x squared? So that's what I'm going to do. I'm going to put x squared, and I'm going to put x squared. All right. Now, how do I multiply to negative 12? Well, there's a couple of different ways to multiply to negative 12. I can do negative 1 and 12, or flip that. I can do negative 2 and 6. I can do negative 3 and 4. Which one is going to have a difference of 4? Now, it's this one, but the signs are all messed up. So we're going to go with positive 2 and negative 6. Now, this can't be factored anymore, and this can't be factored anymore. Now, you know what my favorite thing to do is to punch kids in the nose that do too much. No, I don't hit kids. It's just joking. But do you see any equals 0 here? No, but we had so many kids this year decide to try to solve this. It just says factor it. It doesn't say solve it. Doesn't say solve for x. Now, how can I use my calculator to see if I'm remotely correct? You're not going to know if you're perfectly correct, but you're going to know you're pretty sure you're correct. So here's how we're going to do. We're going to do x to the 4th minus 4x squared, and then minus 12. And we'll type in enter, and that's what that sucker looks like. And then we're going to go tab, and we're going to type in what we got. What we got was x squared. Was it plus 2? And then x squared minus 6. I believe that's what we said it was. And shabam, look at that. Maps right over it. Now, if you don't believe, go check the bottom. Go check the bottom. Look at it. Look at it. You can either hit tab. You can always do this. Press tab, hit the up arrow. Red one, blue one. Red one, blue one. See how they land on top of each other? That means you got it right. All right. Let's move on to number 2. Where the heck is number 2? 26, I mean. Number 26. Okay. Express the following in simplest. Now, this is simplest form. So let's do this. There's really nothing to do with the top right now. You can't do anything. You really got to handle this bottom part. And what this is you got to know that this is 16 to the 1/4 power and x to the 4th to the 1/4 power. Now you have to remember, when you raise an exponent to an exponent, you have to multiply them. And 4 times 1/4 is just 1. So this becomes x to the 1. This you can just put in your calculator if you want to, but if you do, you'll just get 2. Put in your calculator, trust me, it's 2. Okay, now I can simplify. The 2's go, and I end up with this. Well, what do I do with exponents when I divide? I simply subtract them. 3/2 minus 1 is equal to 1/2. So my answer is x to the 1/2. Now, here's the problem. That's a perfectly amazing answer. Watch this. You're going to come over to your calculator and go, I'm going to check to make sure I got this right. I'm going to go over here. I'm going to go, okay, I'm going to say 2.345. Remember, this is any random number. Don't pick anything normal. Just pick a crazy random number. Press enter. Control division. Now, it was 2x raised to the 3/2 all over 16x to the 4th raised to the 1/4. Now make sure that's the way it turns out. Yeah, look at the way it looks. 2x to the 3/2. Perfect. And then I'm going to type in my answer, x raised to the 1/2. I mean, like, woohoo! Same exact answer. Check it out. Same exact answer. I got it right, except you didn't. It's a 2-point question, kids. It's absolutely vital. I almost gave it away at the beginning, but it's absolutely vital that you read. It says in simplest radical form. This is not a radical. That's not the answer. You have to remember, oh yeah, 1/2 as an exponent really means the square root of x. Now, you don't have to put the 2 there, because that means square root. Well, now let me see if I'm right. Let me see if this is right. That was what we got before. I'll do the square root of x, and I see that they're in fact the same. So you got to be careful. This says your answer better be a radical, otherwise you're not getting full credit. All right, that was kind of tricky there. Next one's not so bad. The world population was 256 million people in 1950 and 340 million in 1960. And then we got this crazy equation here. Let me write this down. P of t equals 2560 e to the point 0.017185 t. I think one of the hardest parts about this problem is actually writing down that exponent and not missing one of their crazy numbers. All right, let's do some highlighting here. Nearest hundredth, let's do that. We got millions of people per year. All right, we want to go from 4 to 8. And it says here, this bad thing right here says average rate of change. You all should know that average rate of change just means slope. Okay, so I'm going to plug in 4 and see what I get. Notice I'm going to not round the decimals. And then I'm going to plug in 8 and see what I get, because it says we have to go from 4 to 8. So I'm going to plug those in first. I'm going to go over to the old calculator. Hello, Mr. Calculator. Oh, it's good to see you. Calculator's like your best friend. Makes you dumber. Makes you stupider from Jupiter. But we're going to be all right with that. No, it's all right. Let's put it in for t, because that's what it is. And then we got, I don't remember this crazy thing, 2560. Now, what are the chances that I not miss one of these silly variables? 0.017185, was that right? 185.017. I'm going to erase this just so I can make sure I'm seeing it properly. 017185. And then raised to or times t. And press enter. Now don't round that. It's 2742. 2742.16364. 16364.018. I don't like rounding at all. I like having my answers. Now the easy thing is you just go like this, change this to an 8, go like this, presses enter, and we get 2937. 2937.289.289. This shows the grader that you spent some time, you got the numbers in there. Now I'm going to show you how you get partial credit. I don't know if we've gotten any points right now. This is 2 points. I don't think we have. But if I change the average rate of change, I like to call this AROC. AROC is going to be equal to the change in Y's over the change in X's. And I believe if you just write this, AROC, change in Y's, so I'm going to take big minus small, so I'm going to subtract this way. 2937.298289620. That's enough decimals. 6 decimals enough. Minus 2742.16364. 163,640. All over 8 minus 4. Now remember, if you subtract this way, you have to also subtract that way. And you got to be real careful with that. Now, here's the cool thing. I'm not even going to type those things in. I'm going to say U, enter, minus U, all over. I'll do 8 minus 4 because that's pretty easy. 8 minus 4. See how I didn't type those decimals in? Therefore, I'm not going to make any mistakes in what numbers get put in there. Sometimes you do that, and you forget a decimal, and it's terrible. Just do that, and I get 47.8. Now, I'm not going to round this yet. I get my AROC equal to 47.78149. 78149,518. And then I'm going to go back up to the problem. I'm going to say, oh, nearest hundredth. So my final answer, now you got to be careful. I know I just boxed that in. I probably shouldn't. Is hundredths place. This is my hundredths place right here. 47.78. This is your final answer. I should not have boxed this in, because when you box something in, that tells the teacher or tells the user, oh yeah, that's my answer. You know, star your answer, do what you need to do, but don't only box in one answer. If you box in two answers, we got to average the two, and you don't want us doing that because we always average poorly. All right, let me take a little break. I'll be right back, and I got to get some coffee. Fresh ground Dunkin' Donuts in the coffee machine. Yes, sir. Woo! All right, so we got the scores of the recent students taken by 1,200 students, normally distributed. Bam, I see it. I'm going to draw it right now. As soon as you see approximately or normally distributed, there you go. We know we're going to put mean here, x bar, whatever it is, and we're going to put our standard deviation here. All right, so what we got? We got a mean of 222. I meant 225. And a standard deviation of 18. Determine the number of students who scored between 200 and 245. Okay, so I want this number right here. So I know in my class we did z-scores, we did z-tables, we looked up all this stuff, but unfortunately New York State's decided, nah, we don't want to do that. We don't want to do that. So what we're actually looking for is the probability that 200, whatever. We're trying to look for this probability. We're going to find it out. Let's just look for that probability right now. Okay. So we go over to the old calculator, and let me get rid of all this crap. Now, if you're going to remember correctly, you're going to go into menu. You're going to go into probability, distributions, and normal CDF. You only use inverse normal if they give you the area under the curve. If you're looking for the area under the curve, you use normal CDF. My lower bound was 200. My upper bound was 245. My mean was 225. And my standard deviation, I believe, was 18. Now, what this gives you is the percentage. Do not round. 0.78, 4306, 4306, 37. Good enough. Now, that's not what it asked for, because it asked for the number. We had so many kids, and they rounded that baby to the nearest, I don't know what. Well, actually, this one's hard to round to the nearest number of students. But here we go. We got 1,200 students, and we're going to multiply by this. So I'm not going to type that in. I'm just going to hit times 1,200. Over here, I'm going to say, okay, take this and multiply by, now, I'm probably going to show it like this. 1,200 times 0.78430637 equals, and then I'm going to box in my answer down here. Shabam, 941, not ready yet, 941.1676. 1676. Now, my guess is they said the nearest student, right? Determine the number of students. They didn't even tell you where to round to. If you give this as an answer, you're wrong. The answer is 941 students. Shabam, done. Remember, part 2 should not take that long, except for this one. All right, so I'm going to tell you right now that minus is a problem, and it becomes a problem. So what I'm going to do immediately is I'm going to do this. And this thing should be in parentheses. Okay, so I'm going to highlight all the things you see in the denominators. You see an x plus 3. By the way, you don't see an x, and you don't see a 3. That's x plus 3. That's one thing that you see in the denominator. I also see a 2. I also see a 6. And I also see a 2. So my lowest common denominator. First, if I look at 2, 6, and 2, what's the smallest number that they all go into? 6. So my lowest common denominator is 6. But there is also an x plus 3 in the denominators. So I need that as part of my common denominator as well. All right, so I'm going to change all the denominators to this. So 6 x plus 3 plus 1 over 6 x plus 3 equals, well, I should have put negative 3 here. 1x over 6 x plus 3 plus negative 1 times, oops, we'll get to there, over 6x plus 3. All right, so now what we have to determine is, that's weird, why that's doing that. What we have to determine is, how do I go from this to this? Well, in this case, I just had to simply multiply by 6. How do I go from 2 to that? Oh, I had to multiply by 3 and x plus 3. How do I go from 6 to this? Oh, I have to multiply by x plus 3. And then how do I multiply from 2 to get here? Oh, I got to multiply by 3x plus 3. All right. Now that I've changed all the common denominators, all the denominators are the same, and I figured out what I needed to do, once I've done that, now I no longer need the denominators, because all I have to do is set the numerators equal to each other. Now be careful writing this down. You get negative 18. Now this is 3, correct? So 3 times x is plus 3x plus 9 equals x squared plus 3x. Now this is negative 3. So negative 3 times x is negative 3x. That's why that negative was so awful. You had to be really careful with that. And then negative 3 times 3 is minus 9. Now, this dictates everything. Here's our x squared. You know you're going to end up factoring. You also know you're not allowed to have a negative x squared if you're going to factor. So that dictates everything. So all of this stuff is going to go over to that side. So I'll add 8. Wait, hold on. Let me clean this up over here. Negative 18 and 9 is negative 9. So this is really 3x minus 9. And this side is equal to x squared minus 9. That's weird, because these go. Right? And so I'm going to bring all this stuff over. I'm going to subtract 3x, and I'm going to add 9. Subtract 3x and add 9. Oh my gosh, that's weird. So what I end up with is 0 equals x squared, wait, these cancel, minus 3x. Oh, we're almost done. Now we have to factor. And what? It's got 2 terms. I don't know what to do. First rule of factoring. First rule of Fight Club? Don't talk about Fight Club. First rule of factoring? G, C, F. What do they have in common? Oh, they have an X in common. That's it? That's all I got to do? Yeah. This is one of the longer 2-point questions. You get X equals 0 and X equals 3. Those are your 2 answers. Now, unfortunately, because this is a rational expression, you must check your answers. Now, why wouldn't you want to check them anyway? You want to make sure you're correct? So, let's check them. We're going to take 0 and store it into X, Control var X. And then we're going to type in the left side. Control division, negative 3 over X plus 3 plus 1 over 2. 1 over 2. Now, I'm not going to type the equal sign. I don't like that equal sign. That equal sign is bothersome. So I'll just do control division, X over 6 minus 1/2. And I get negative 1/2. Hey, 0 worked. Now let me try 3. Because I think 3 was my other answer. Type in the left side. Type in the right side. 0, 0. So 0 equals 0. They both work. Now, do me a favor. Make yourself look like you care. Make yourself look like a professional. Okay, you know the answer to that. Make them look all pressed. My answers are 0 and 3. Box this in. Check. Cha-chang! That's a long 2-point question. All right, so I forgot how much trig's on this freaking test. All right, so this one's not bad. A equals 3. This is A. This is B. This is C. We always start graphing from C, by the way. B is 2. I always go to period next. period is equal to 2 pi over b, which is equal to 2 pi over 2, which is equal to pi. Now, what does this mean? That means it's going to finish one full curve in pi. The period represents the number of times it finishes one full curve. How long it takes to finish one full curve. The frequency is the number of curves in 2 pi. All right, we're almost ready. Let's do x scale. My x scale, the way I do it, is period divided by 4, because I always say you need 4 tick marks to graph the sine function. So we just take pi and divide by 4, and lucky for us, we don't even have to reduce that. My c value is 2, and that's where we start. My max is c plus a, so that's 5. And my min is c minus a, and that's negative 1. All right, we're ready to graph. I'm going to have to shrink this just to get this on here. So the first thing, you always start at the midline. Actually, we got to put our scale on here first. Let's get our scale on here first. All right, we're going to go up by 1s. And we need 4 tick marks, and we want to go by pi. So I'm just going to go pi over 4. 2, 3, 4, and this is pi. That's enough. 1, 2, 3, 4. Now, why did I go all the way out to 2 pi? Because I believe the directions said graph from 0 to 2 pi. So we had to do that. All right. Got my scale on there, looking pretty. Let's get my... this is almost impossible for me to draw, but remember, my midline is a dashed line. A dashed line is only like a construction line. It is not part of the graph, and nobody grades it as part of the graph, but there it is. Now, you have to remember this, kids. A cosine curve starts at a max, goes to a min, and comes back to a max. Mrs. Newman likes to call this the uterus. I apologize if anybody's offended. I don't actually care. That's what she calls it. And she's a female teacher, so I don't know. That's just weird for me. A sine curve starts at 0, ends at 0, and it's got 0 in the middle, and it goes up and down and back up. So we're doing sine curves, so we don't have to even worry about that. So we're going to start on the midline. Now, when does it end? It ends at its period. The period is right here. So it starts at a 0, it ends at a 0, and it's 0 in the middle. We already calculated the max. The max was 3 up. 1, 2, 3. And we even said that's going to be 5. Let's count. 1, 2, 3, 4, 5. And the min is going to be at negative 1. Well, that's clearly negative 1. And so I graph my sine curve. Boom. Okay. By the way, I'm going to show you how to use the calculator to kind of make sure you know you're approximately correct. All right, let's do the second one of these curves. Starts at a 0, ends at a 0, 0 in the middle, goes up to a max, and down to a min. And we do the second curve. And there you go, kids. That's 2 points. That's a lot of 2 points. Now, let's use our calculator to see if that's right. So what we're going to do is we're going to set up our window so it looks exactly like this one. So here, I'm going to go back over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we want to go from 0 to 2 pi. So let's go to graph mode. You got to make sure you're in radians. We're going to make this, I'm going to make this 0. And this 10. And this 2 pi. And this negative 10. So now what I have is, whoa, look at this scale. The scale's nasty, nasty. I want to change the scale. So I can do that in menu and window settings. I wonder if I can do it right on the graph. Let me just check. That would be cool. Oh my gosh, I can change it right here. Oh, that's going to be a game changer, kids. I got to teach my kids that. I just learned that. Pi divided by 4. That's like a game changer right there. Look at that. Now I got my scale on there. So this graph ought to look exactly... I did not know that. That is the coolest thing ever. Now, by the way, if you ever want to see the y-axis, if you just hover right here, click and hold, it turns into a little hand, and you move it just a little bit, you can see the x-axis or the y-axis, and that's kind of nice because now I see this y-axis. All right, now I'm going to press tab. I'm going to graph this thing. 3, sine 2x plus 2. I believe that's what it was, right? There it is. And press enter. And hopefully it looks exactly like what we graphed, right? We started at 2. We started at 2. We ended at... Oh, we can't see this over here. You know how we move this over? We need to go back and change this to 2 pi. That would be a mistake. 2 pi. Okay, so started at 2, ended at 2. Right? One full curve looks exactly like our drawing. Very good. Perfect. All right. Okay, kids, I'm going to solve this algebraically, but I'm not. I'm not going to do it. I refuse. I'm just kidding. I'm going to, but before I do that, what I'm going to do is I'm going to figure out what the answers are. I'm going to put those answers right here. I'm going to put them right. I don't even leave myself room here. Now, why am I doing points? Oh, yeah. When two graphs hit each other, they hit each other at points. Now, hopefully you know this is a circle, and hopefully you know this is a line. So my guess is it's probably going to have 2 points of intersection. Not exactly sure, but probably. So let's go graph these things, and let's see if we can use the count. That's not where we want to be. All right, so get out of here. Goodbye. So long, all that good work we just did. All right, so in order to graph a circle, though, you can't. A circle's not a function. You have to graph it as a relation. So it's x squared. And you can do this on the 84, I believe, too. You can graph a circle. Equals 400. Shabam. What in the heck? I did not type that in right. X squared plus y squared equals 400. I'm going to erase this and start over because I don't know why that happened like that. So I'm going to backspace. I'm going to choose 6. I'm going to go x squared plus y squared equals 400. Oh, yeah, kids. Oh, yeah, I know why you can't see this. Oh, that's a great question. I almost fell for it. I didn't use the calculator when I was making this test prep up, and I was like, oh, my gosh, I almost fell for that. By the way, is this a 4-point question? Is this a 2-point question? Ooh, this is a bad 2-point question. So here's why you can't see it. Remember, the center is at the origin, and that's where you show see that little circle, that little blue thing right there? But the radius is the square root of this. And the square root of 400 is 20. So I'm going to go negative 30. Negative 30. Tab 30. Tab 30, tab, and then I'm going to go with negative 30. Now, it looks a little ovally. Oh, that's only because, you know, it's just the box is kind of rectangular. And then I'm going to press tab, and I'm going to graph the other one. Y equals x minus 28. All right, boom. Uh-oh, looks like there might be just one answer there. Looks like there's just one answer. So here's what we're going to do. We're going to go to menu. Now, when you graph relations on this calculator and you try to do intersections, you no longer get a dotted line. You get this thing called first corner. See it here? And I get a little dot, first corner. All you got to do is draw a rectangle. So what I'm going to do is I'm going to draw a rectangle around until it tells me there's a point of intersection right there. Wait, there's another one. Look at that. There's one up there and there's one down there. You got to be careful. Looks like there's 2. Wow, that doesn't look like there's 2 though there, does it? Menu, let's do it again. 6, intersection. There's 2 of them. There they are. We got 16, negative 12, and 12, negative 16. So I'm actually going to put those over here. 16, negative 12, and negative 12, 16. So those are my 2 answers. All right. I get nothing right now. Although I do know what the answers are, I got no credit. Remember, this is only worth 2 points. How can this problem be only worth 2 points? Look at how much work I got to do. That's crazy. All right, here's how it works. It's not difficult, though. You guys can handle this. What we're going to do is a little substitution. We're going to take this, and we're going to substitute this in for y. So I get x. Well, that's not very easy to look at. Let's do it in this nice, bold black color. So I get x squared plus. Now, instead of y squared, I'm going to write x minus 28 squared equals 400. So this is x squared minus, or excuse me, plus. I'll write it out for you. Some of you need to see this. So this gives me x squared plus x squared. Now this is minus 28 and minus 28. That's minus 56x. And negative 28 times negative 28 is that 576? No, 384. No, 784 plus 784. Let me make sure that's right because I'd hate to be wrong. 28 squared. Notice how I'm not putting the negative in, right? Because this is what happens when you put the negative in. And you all get all crazy stupid on me. Negative 28 squared. Bam. See how it's negative? When you square something, it's always positive. So there's no real reason to put in that negative. Just put in 728 squared. 784 equals 400. Subtract the 400 over. I get 2x squared minus 56x plus 384 equals goose egg. Since they're all even, I can take out the 2. I'm left with x squared minus 28x plus 192. Yeah, half of this, right? If you subtract 400, enter, and then divide by 2, I get 192. So plus 192 equals 0. Now I'm going to factor this. X and x. Now see how this is positive? That means both these have to be the same sign. And since this one's negative, they both have to be negative. So minus, and I already know it's 12 and 16. How do I know that? Look at my x values. My x values are 16 and 12. By the way, I didn't even copy these answers down right. Isn't that embarrassing? The answers were 12 and negative 16, 16 and negative 12. So I should have copied those down correctly. It's 12 and negative 16 and 16 and negative 12. Whew, man, that was dumb. Almost made a dumb mistake. Because look at here. Here's my two answers. X equals 12 and x equals 16. Now, all of that work would be worth 1 point if you don't go back and find the y values. Because it says solve the following system algebraically. And that, when you solve systems, you're going to get an x and a y value. So all of this work, you only get 1 point because you didn't find the y values. And you need to show that. So y is equal to x minus 28. Plug that in, and I get y equals negative 16. Y equals x minus 28. Plug that in, and I get y equals negative 12. So, therefore, these are my answers. There they are. Let's box those suckers in. Now I have full credit, and these are, in fact, my answers. Sweet. All right, that one's... All right, here we go. So this is a 2-point question. It shouldn't take very long. Let's see what we got here. By the way, every time you see one of these graphs, and you know somewhere it's going to say this because that's all New York State decides to do, 95% of the data. 95% of the data is always 2 standard deviations. And almost always they give you everything you need right here. Mean and standard deviation. So let's write that sucker down. So some smartphone applications can contain in-app purchases. Special content application. A random sample of 140 users found that 35% made in-app purchases. A simulation was conducted with 200 samples of 140 users. That means if I had to, my n value, by the way, would be 140. Okay. Assuming 35% of the samples make in-app purchases. All right. Notice this is centered right around 0.35, which is that 35% they were talking about. And we're going to go out a little bit here and out a little bit here for our, I believe they're asking for margin of error, right? Look, they're asking for margin of error. So my margin of error should be somewhere, for 95%, should be somewhere about that. Well, remember, this is 2 standard deviations. So normally they ask for a 95% confidence interval, and you would go, okay, 0.350 plus or minus 2 times 0.042. Almost every single one of these exams says, hey, give me a 95% confidence interval where you think the true population mean belongs. Okay, and then you would just do that. You would just add and subtract 2 standard deviations. That's not what this question's asking for. This question's slightly different. They're asking just for the margin of error. And this here is your margin of error. In other words, this is the center, and this is the how spread out you got to get to have a 95 or a margin of error and be 95% confident. So I'm just going to write margin of error equals 2 times 0.042, which is equal to 0.084, I believe. Let me just make sure so I didn't make any stupid mistakes, because I like to make stupid mistakes, just like you, times 2, 0.084. So this is my margin of error. Now, if you just stop right now, you get nothing, no credit. But I have the margin of error, Mr. Krause. I should get something. No, you don't. Because there's 2 problems to this, 2 parts to this problem. One is round it to the hundredths place. Well, we didn't quite do that, did we? That's why you should always, always highlight hundredths place. See how it's italicized? If you see something that's italicized, hey, McFly, you better do something about it. I'm talking to you. Okay, so we got to round it. So I'm going to find my final answer is margin of error. You can just write ME if you want. Margin of error is equal to 0.0. You should probably write 0.08. So there's my margin of error, 0.08. Now, got 1 point, because the rest of it says, in context, explain what the value represents. In context. In other words, I almost didn't need any of this up here, because it's all about blah, 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 blah. Tell me what my 95% confidence interval is. Tell me what 95% margin of error is. However, because I have to explain in context what this margin of error represents, I got to do a little bit of wordsmithing. So here's what it is. We think the true mean is 35%. Okay? But what we want to do is but we're not 100% sure. So we have a margin of error. So what that means is we think that 35% of people make in-app purchases. However, because of the margin of error, we're not exactly sure. So it's either going to be, so something like this. If we sample 200 people, we would expect, I should probably change colors, expect to find, or to have, or to get, how about that, to get a mean within 0.08 of 0.35. I did not put this in context. If we sample, I have to do this in context. If we sample 200 people and ask if they make in-app purchases, we could expect the average to be within 0.08 of 0.35, 95% of the time. In other words, we take a sample of people that make averages. We expect our average to be somewhere within 0.08 of the 0.35, 95% of the times. You could also say 5% of the times it would be over 0.08, away from 35%. Something to that effect. All right, that ends part 2's. I'll be right back. Oh, hey, you're back. I got my coffee. All right. So we're going to solve this system of equations algebraically, except I'm not. Okay, yes I am. But the first thing I'm going to do is start with my answers. I want to know what the answers are. So I'm going to start with the answers. Let me get rid of all this crap. So I can use my calculator. If you got matrices on the TI-84, you can use that as well. But I'm going to solve a system of equations. So it's algebra, solve a system of equations, solve a system of linear equations. I got 3 equations. Press tab. They used x and y, so I'll use x and y. Press OK. And let me do this really quick. We'll move that over. Yeah, move it over just a little bit more so I can see them. So 2x plus 3y minus 4z equals -1 down. X minus 2y plus 5z equals 3. Negative 4x plus y plus z equals 16. Now, if your answers turn out to be crazy like those, okay, I didn't do this on purpose. I'm going to tell you that right now. I was moving too fast. Those are crazy answers. Those are not going to be what your answers are. So if you end up with answers like that, old glasses on, look to see what stupid mistake you made. So re-highlight this. Let's do this again. 2x plus 3y minus 4z equals -1. Looks like I got that one right. This says x minus 2y plus 5z equals 3. That looks good. See right here, -2x. It should be -4x plus y plus z equals 16. Much nicer. And I did not do that on purpose. So what I'm going to do now is I'm going to actually write down what the answers are. X equals, y equals, z equals, -2, 5, and 3. -2, 5, and 3. So I know when I'm done, those are my answers. Now I've got 0 credit right now because who cares if you can use your calculator? Nobody cares. This is not like part 1 where you can use your calculator. All right, so what we're going to do now is we're going to take a look at these letters. You need to look at all 3 equations, and you need to find the one that looks like it's the easiest to get rid of. So I look at 2x, I can make that 4x. I can make x a 2x. That x looks like the easiest. I got 3y and 2y. I can't make a 2 into a 3, but I could do both of them into 6, but that's kind of a problem. 4 goes into 5. Now, clearly the x's are easiest to get rid of. So we're going to get rid of the x's. You can't just get rid of them. So what we're going to do is we're going to take 2 of these equations. Now, I always say make one of them negative, make one of them positive. So I take this second equation, and if I multiply by -2, I would have -2x. Now, the trick is you got to make sure you multiply everything, the whole left side and the whole right side, by -2. All right, so let's write this up. 2x plus 3y minus 4z equals -1. Missing one sign blows the whole problem out. Slowly go, or not writing a number incorrectly. So I'm going to multiply -2x. -2 times -2 is positive 4y. -2 times positive 5 is -10z. And -2 times 3 is equal to -6. Again, missing just one sign, you're screwed up. So we got 7y minus 14z equals -7. Okay, so there's one of our cleaned up equations. Now what we're going to do is we're going to group these 2 together. And now I'm going to multiply the middle one by 4. Now, notice if I multiply 4 times x, I get positive 4x. And this is -4x. So that's pretty good. That's what I want. So 4x minus 8y plus 10z equals, just made a mistake, right? Plus 20z equals 12. Again, I just multiplied all of these by 4. So 4x minus 8y plus 20z equals 12. One mistake and you're shot. You got to start all over again. So -4x plus y plus z equals 16. All right, again, these go, and I end up with -7y plus 21z equals 28. So now I'm going to put these two together. Now if I look at it, look at the y's. Look how pretty that is. Those y's, if I put them up on top of each other, the y's go away. So I'm going to write that out. 7y minus 14z equals negative 7. Negative 7y plus 21z equals 28. Now beauty is I can just add those. And I get, well, these go. And I get 14. Oh, where is that coming from? How about 7? 7z, negative 14 plus 21 is 7, equals 21. Divide by 7, I get z equals 3. Now you're crossing your fingers, you look up. Woohoo! Ka-chang! Now we're going to use one of these equations. Which one's more positive? How about we go here? Actually, this one's got more positives. I'm going to put it in this one. It's got more positives. So I'm going to go negative 7y plus 21 times 3 equals 28. So negative 7y plus 63 equals 28. Now in my brain, I'm thinking that's wrong. There's no way that's right. 28 minus 63 equals negative 35. So I get negative 7y equals negative 35. I divide by negative 7 and I get y equals 5. Cross my fingers. Catching! Now I'm going to go back to the original problem. Don't erase your work, but I'm doing it. And I want to find the one with the most positives in it. Okay, it looks like this is going to be the easiest one to work with probably. Oh, wait, hold on. I'm looking for x. I might as well choose this one because that's got a plain old x. So when I'm done, I got a plain old x. So x minus 2y. I'm going to look down on my paper so I don't have to look up. X minus 2y plus 5z equals 3. So x minus 2 times 5 plus 5 times 3 equals 3. So x minus, this is 8. That's negative 10 plus 15 is plus 5 equals 3. Subtract 5, I get x equals negative 2. Done. Check. And there's no reason to check because you already did. You started with the answers. Alrighty, the 4-point question for this. I'll be right back. All right, evaluate j of negative 1. Okay, so if they tell you to evaluate it, you probably should show some work. Let me try to write neatly. J of negative 1 is equal to 2. Anytime you sub in, use parentheses. Negative 1 to the 4th minus negative 1 cubed minus 35 times negative 1 squared plus 16 times negative 1 plus 48. Now, I am not showing in between values on this. In fact, I'm not even going to do the problem that way. All right, so here's what I'm going to do. Let me get rid of my last problem. Here's what I'm going to do. I'm going to take negative 1 and store it into x, because I know if I don't do this correctly, I'm going to be in trouble. And by the way, you can do this on the 84 plus or 83s as well. They got a stow button. Just use the stow button. I got to use negative 1 because that's what they told me to do. And then I'm just going to type in this. What the heck is my thing? I'm going to type in this up here. So 2x to the 4th. I'm going to look down while I do this so I don't have to keep going back and forth. It's 2x to the 4th, so 2x raised to the 4th minus x cubed minus 35x squared plus 16x plus 48. And I get 0. Oh, so it equals 0. So the question says, explain what your answer tells you about x plus 1 as a factor. So since j of negative 1 equals 0, by the remainder theorem, we know x plus 1 is a factor. By the way, this question is just dumb. Why would you ask you that? But whatever, it is. It is what it is. So algebraically determine all the zeros of x. So we got to algebraically determine it. Now, I'm going to tell you right now, I'm going to find them right now. There's 4 of them. I'm going to find them right this minute. And I'm going to show you how. Menu 331. Menu. Now, mine's a little bit different. Polytools. Find the roots of a polynomial. This is a 4th degree polynomial. Always choose complex because we're in Algebra 2. We might get imaginary answers. And we're going to type in just the leading coefficients. So 2, -1, -35, 16, and 48. And there's my answers. -4, -1, 3 halves. I don't know where my marker is. So -4, -1, 3 halves, and 4. Now, I get nothing for that. Nothing, because they don't care that you can use your calculator. But we are going to know when we're done we got the right answer. So we're going to do some long division, kids. X plus 1. So 2x to the 4th minus x cubed minus 35x squared plus 16x plus 48. Now, this problem requires a ton on it. So first things first, you see you got a 4, a 3, a 2, a 1, and nothing. You got to make sure there's no missing terms because you're going to have to add one in there, a 0x cubed if there is. All right, x times 2x cubed gives me 2x to the 4th. So I multiply by both of these, plus 2x cubed. Come in, subtract, change the signs. So I get -3x cubed minus 35x squared. Again, you mess up one sign, you got to start all over. And since you're working in pen, that sucks. So just take your time. So x times minus 3x squared. So this is minus 3x cubed minus 3x squared. Change the signs. This goes to a plus. This goes to a plus. So now we're at -32x squared plus 16x minus 32x. So we get minus 32x squared. Minus 32 times 1 is minus 32x. Now you know you're going to be right at the end if we get a remainder of 0, because by the remainder theorem, we should have a 0. So this gives me 48x. Now bring down the 48. I hope it was a plus 48. Yep. And then I'm going to say, okay, plus 48. 48 times x is 48x. 48 times 1 is plus 48. Change the signs. Minus, minus, and this goes to 0, which we should and we knew we were going to have. So what they want now is for you to finish factoring this to get those answers. Now, we already know 1 is the solution. So, we got to factor this thing. So let me write it right here. 2x cubed minus 3x squared minus 32x minus or plus 48. All right, so we're going to group these two. And we're going to group these two. So, I can take out an x squared, and I'm left with x. Control Z. I'm left with 2x minus 3. Copy over the sign, minus. I can take out a 16 out of these, and I'm left with 2x minus 3. Now, if those parentheses don't match, you done screwed up. Like, for example, if you thought the only thing you could take out was 4, then you wouldn't have the parentheses matching. If you thought the biggest thing you could take out was 8, then you wouldn't have those parentheses matching. The biggest thing is 16. My first set of parentheses is 2x minus 3. My second set is x squared minus 16. So 2x minus 3 is one of them. X squared minus 16. Now I'm going to factor the x squared minus 16. So 2x minus 3. X plus 4. X minus 4. And now I got my two answers. or my next three answers. X equals positive 3/2, X equals -4, and X equals +4. Now, did it ask for all roots or just the remaining roots? It said algebraically find the remaining roots. So your answer that you're going to give is your final answer, and you're going to box it, is 3/2, -4, and +4. Boxing it. Now, I'm pretty certain if you box this in, they might give you this okay. But remember, this is all the answers, and they just asked for the remaining zeros, and there they are. All right, this problem is actually really, 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 really easy, except for one thing, and that you have to remember what this means, compounded continuously. Let me highlight 10th of a year, too, so when we're done, we know we got to round to the 10th of the year. You need to remember that compounded continuously is this equation. It is my hair shampoo, Pert. I don't even know if they make Pert shampoo anymore, but Pert. They used to make it. So P stands for the principal or starting amount. This is the key right here. Anytime you have compounded continuously, your base has to be E. It's not a 10% growth and 8% growth. It is compounded continuously, so E has to be your base. All right, now we're ready to go. Oh, we got one other tricky thing. This is 3.75%, which as a decimal is 0.0375. Now, if you know these two facts, bodied. Oh, yeah, that's how cool people talk. We sit with bald head. The problem's over with. This problem's so ridiculous. Oh, wait a second. There's one other trick. And this is what always gets kids, and I forgot about this problem. So let me take this back. This problem is really, really, really easy mathematically. Very difficult to put all the pieces together. So first, compounded continuously, you needed to know principal e to the RT. Changing that 3 3/4 rate to 3.75 and then 0.0375 to, and then they didn't even tell you how much money you have. Okay, when they don't tell you how much money they have, you make it up. Now, this is an SAT trick as well. Always make it up as 100, because dealing with 100 is easy. So if I started with 100 and I wanted my money to double, I would end up with 200. And that's the last trick. Now it's a joke. So our final amount is 200. Our starting amount is 100. E to the 0.0375 t, and now the math becomes really quite simple. I'm going to divide by both sides by the weird thing, or I'm going to get the weird thing alone by dividing by 100. And I get 2 equals e to the 0.0375 t. You need to log this, but because it's e, you have to natural log. So natural log, base e, but you're not going to be allowed to put that in a calculator, but that's where the base goes. Logs are equal to exponents, so 0.0375 t, and the 2 drops in the hole here. Now, in order to get t by itself, we're going to divide by 0.0375. 0.0375. And I get t equals, and now I go to the old calculator. Control division, natural log of 2 divided by 0.0375, and I get 18.4839. 18.4839. I remember from the beginning it said to the nearest, I believe, tens. Let me make sure. Nearest tenth of a year, so my answer is going to be 18.4. You don't have to put units on it. They always tell you what the units are, so 18.4. There we go. Right? All right, there's one more trick, because that's not the answer. Sorry, I forgot about this question, and I was just thinking about it. I'm like, oh, God, oh, no, that part of it. Okay, determine to the nearest tenth of a year how long it would take for an investment to double. At 18.4 years, at 18.4839 years or whatever, or at 18.4, did it double? It's not doubled yet. It's almost doubled, but it's not quite doubled. So in order to make sure that it's doubled, you have to go to 18.5. Really hard question. You know what? I forgot about that question. That question, the math was not difficult. All of the other stuff for that problem was very, very difficult. Very difficult. Wow, that was a tricky, tricky question. All right, sorry, I didn't mean to make you feel bad about yourself. All right, let me pause for a second, get some coffee, and we'll tackle this question. Alrighty. Ooh, forgot to grab a coffee. Yes. All right, so to determine if the type of music being played while taking a quiz has a relationship to results of 16 students were randomly assigned to either a room softly playing classical music or a room softly playing rap music, neither of which would be anything I would listen to. A little Metallica loudly playing would be what I'd like. None of this stuff, but whatever. So the question says, John correctly rounded the difference of means in his experiment group to be as 7. How did John obtain this value? And what does it represent in context? How did he represent? Okay, I'm not going to go through the math of rounding these things. I think you guys can handle rounding. If you take these up and add them on the classical side, I believe you get 82. Oh, I better check this. I'm going to pause. I'm going to do it on my calculator so you don't have to wait and watch me. All right, I took the time. I got 82 and 74.625. So I was in fact correct. X bar equals 74.625. So 74.625. Now, if I subtract those, why does that keep coming up? If I subtract those, this one minus this one, I get 7.355. So, John, okay, you got to explain. So, explain. Well, John determined classical average to be 82 and rap to be 74.625. Now, I don't know exactly what they wanted to correctly rounded it. How did Jane attain these values? By adding the scores. Let me try to write neater. Scores and dividing by 8. The difference was determined. Cannot write with this pen. Determined by subtracting them. As dumb as this sounds, make sure you answer the question. Okay, now what does it mean in context? What this means, this appears to mean, is listening to classical music improved, is this quiz scores? Quiz scores by, well, improves quiz scores by an average of 7%. Something to that effect. Basically, if you listen to classical music, besides falling asleep, sorry if you like classical music, then it'll improve your quiz scores by 7%. I don't know exactly what they were looking for there, but that's about right. That's about all you need to say there. Here's the most important part. Here's the part you're probably here for. Determine if there's any significance value. Determine if there's any significance in this value. Wait. To determine if there's any significance in this value. I knew I was reading that wrong. John re-randomized the 16 scores into 2 groups and calculated of 8 and calculated the difference. And then he did it over and over and over and over again. What he's trying to eliminate is sampling variability. In other words, Did you accidentally just get all the smart kids in the classical and accidentally get all the not smart kids in the rap group and then check their averages? So if he re-randomized it, and what he found was it looks like it averaged about 0. But it had some margin of error, right? So where would we see a difference of means of 7? Well, or worse. So let's see. 1, 2, 3, 4, 5, 6. So here's 7 or 8. So we would only expect to see a score of 7 or worse or different. How many times? Well, 1, 2, 3, 4 times. 4 times out of 250. Now, what they're saying then is, does that seem very likely that you would find? So let's assume there's no difference between classical and rap, and we ran these samples. Then we would, if there is no difference between them, then we would only see this difference 7 out of 250 times. That's not very likely. So if there is no difference, this difference of 7 should never, ever happen. And yet it did. And the only reason you can account for it happening is because, there is a difference between listening to classical music and rap music. So, does this simulation support the theory that there may be a significant difference in quiz scores? Explain. Does it support the theory? Yes. It supports the theory. Boom. That's yes, it does. If there is no significant difference, then a difference of 7% would only occur. Now I'm going to figure out what this percentage is. 7 divided by 250. 0.028. That's 2.8% of the times occur. 7% or more would occur by chance only 2.8% of the time. Now, the cutoff is 5%. If that's less than 5%, then it is a significant difference. If it's more than 5%, not so much. Since this is less than 5%, there must be a reason for it, and according to this scenario, it has to do with classical music. It has to, I am terrible at writing with this pen. It also has to be because of the music choice. So make sure you understand this. We saw that there was a 7% difference. We had calculated it. We saw there was a 7% difference. They said, okay, let's just re-randomize, and see what happens. Okay, so if you take those scores and re-randomize them, and you subtract their averages and subtract those averages, and you do that 250 times, an average this low right here, as high as 7% difference should never happen. Well, it should happen 2% of the time. Since that doesn't happen very often, then their claim has to be true that listening to classical music has a increasing effect on your quiz score grade, which not on mine. All right, kids, that was kind of a tricky question. There's been a couple hard 4-point questions. This one is not a hard 6-point question, which was kind of nice. Let's see if I got time to finish this. I don't, and then I'll be right back. Alrighty, this one's not bad. This one's not bad. So a major car company analyzes its revenue. Revenue is money, and you got to know this. This is just stuff you have to do. Money, taking money. Let's say it's the money coming in, and C of X your cost. That's money going out, and you always want your money coming in to be more than your money going out. Otherwise, you're not making any money. Over a 15-year period, the company represents its revenue and costs as a function of time in years X using the given functions. Okay, so the company's profits can be represented as the difference between its revenues and its costs. So you kind of need to know that P of X, profit, is equal to revenues, how much money you bring in, minus your costs, how much money that goes out. Now, we're going to put these in. I'm going to try to do this. But you need to make sure that when you substitute in using parentheses. Now, I got to write kind of small because there's a whole lot of crap I got to write here. So, P of X equals R of X, which is 550 X cubed minus 12,000 X squared plus 83,000 X plus 7,000 minus parenthesis 880 X cubed minus 21,000 X squared plus 150,000 X minus 160,000. So in order to save a little bit of time, I'm going to do this. I'm going to distribute this negative here. So this goes to here minus, this is a plus, this is a minus, and this is a plus. So 550x cubed minus 880x cubed is minus 330x cubed. Minus 12,000 plus 21,000 is plus 9,000 x squared. 83,000x minus 150,000x is minus 67,000x. And 7,000 plus 167,000 is 167,000. The only one I'm not 100% sure of is this 83 minus 150. Oops. Let me just make sure I got that right. So negative 67,000. Okay, so there you go. I don't know how much that's worth, probably 2 points. There's our equation. So now what we need to do is we need to, on the next page, graph this function, but we are only allowed to graph from here to here. So let's rewrite what our function is. P of X equals 330 negative 330 x cubed plus 9,000 x minus 67,000, this is x squared, x plus 167,000. So we're going to go to our calculator. Now, you ain't going to see anything, and you should know why. You already should know why you're not going to see anything. So negative 330x cubed plus 9,000 x squared minus 67,000 x plus 167,000. Press enter. Now, of course, you're not seeing anything. Those numbers are 167,000. So the easiest way to figure out how you're going to do your window in this particular case is probably just to go to the table. Now, they only want you to go from 2 to 16. So at 2, it looks like our low is 66. Wait, 38, 21,000, 15,000. 15,000 looks like it's the low so far. $92,000 looks like it's the high. So if I went from up to 92,000 and as low as maybe 16,000, we should be good. So let's go back to, let's get rid of this Control T so I can see what this thing looks like. So again, I'm only going, so I don't care about this. I'm going to make this -1. Oh, I'm going to make this -1, tab. Now, this one has to be as high as 92. So I'm going to make it 100,000. Tab. Oh, it looks like I can start seeing it. Now, I want us to go to 16, so I'm going to go to 20. Tab. Now, you can't see it, but I'm at the bottom one. And I'm going to make this one, what do we say we're going to make this bottom one? 10,000. All right, there we go. That's what it's going to look like. Oops, it's hard to see that one. So when I'm done, that's about what it should look like. All right, so let's go to the, so I need to get to 100,000. There's 10 boxes up, so I'm going to make every one of these, I believe, 10,000. 20,000, let's make this 30,000. 40, 50,000. 60, 70,000. And 90,000. Okay. I want us to go from 2 to 16, but we got to go to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. All right, now is here. Now all we do is go Control T, and we go to our table. Start at 2. At 2, we're at 66,000. You're not going to get any more specific than that. At 2, we are at 66,000. So there's 60. So 66 is somewhere in the middle. Now look, it's a dot. We're going to start there. We're going to end. No arrows because it told us where to start and end. 38,000 at 2. There's 40. 38,000. 22,000. There's 20. 22,000. At 4. 25 is 15,000. So 16,000. 6. 17,007. So that's 18,000. Oh, I hate that. 26,000 at 7. Oh, what was 6? 18,000. Why did that go away? 28,000 at 7. Oops, 26,000. Oh, that's about right. Oh, stupid computer. 38,000. 52,000. 67,000. Almost 80,000. 87,000. Oops, 13. What the hell happened? 11 was 80, almost 80. 12 was 88. 13 is 92. 14 is 87. 15 is 73. And 16 is 43. Now, I'm going to tell you something. You also should find the max and you should also find the min, just in case those are particular questions. So what we do is we go Control T. My guess is the min and max are probably going to have to do this question. They always have something to do with questions. Where's my minimum profit? Where's my maximum profit? Remember, this is my profit equation. So I'll go menu, oops, escape, menu, analyze graph, minimum. It's over here, click. It's at 5.22. And what is that thing? Okay, 5.22 and 15,600. So 5.22 and 15,500. So somewhere right around here. Okay, so all right, but we got to find the max. So menu, analyze graph, maximum, click, 13. And see how this is like this? If you just right click on it and you choose attributes, you can change it so you can go, so 92. So 13, oh, it's at 13 and 92. So there is the maximum. Now, as far as getting credit, I would write them in here. 5.22, comma 15,557 and 13, comma 91,996. 91,996. That's the max. All right, we're almost done. Over the given domain, state when the company has the least profitable and most profitable to the nearest year. Explain how you determine your answer. Okay, so least profitable is at T equals 5 years. Most profitable, I told you this was not a hard question, at T equals 13 years. I feel like I didn't find the max right. Menu, analyze graph, maximum, click. Yeah, there it is, 13. Okay, so 13 years. I used my TI Inspire calculator to find the value of the relative min and relative max over the interval from 2 to 16. That's it. We're done. Problem's over with. Buddied. I believe that's the end of the test. Woohoo! We finished. Listen, subscribe. Keep studying. Keep working. I have a ton of review material right here. You go over here and review. You got Algebra 2, Common Core. These are all the Regents exams. I just finished this one, and I'm going to be doing January next. But if you want more review, here's some more awesome review material. Here's so much review. If you're not good at factoring, if you're not good at trig graphs, you're not solving equations, not good at the remainder theorem, exponential, all this stuff. All of this stuff is good reviews. Plus, I got some more reviews. And I got final reviews. There's so much stuff you can review. There's not enough time to review it all. So hit it up. Go work. Keep working. And let me know how you do. Okay? And hit the subscribe button. Thanks, kids. Catch y'all on the flip side. Goodbye.